Welcome everybody to today's seminar. I'm glad you're here. There's going to be a really exciting barbecue afterwards. Before I forget, if you're going to the barbecue, bring your chair. You have to carry our chairs over there. So we do have a few announcements today. Welcome.
Oh, hi, for those who don't know me, I'm Malcolm Bowman. A couple of events coming up of wide interest that you will invite to. The first one is a week tomorrow, Saturday. There's something called Stony Brook Harbour Day. The Stony Brook Harbour is a beautiful harbour. It's probably the most interesting harbour on the offshore Long Island. It's under threat. It's under threat by some very wealthy folks who live around the harbour perimeter want to build 200-foot docks for their mega yachts dredging the harbour. So there's a concern, and it's also a chance to. They have asked me to make a tribute to a former professor and former dean here, Larry Swanson, passed away a few years ago. Larry and I wrote this book, so I'm going to make a tribute to Larry, and also Jeff Levinson, professor of ecology and evolution, will be there also talking about things. That's Saturday, a week tomorrow. See me at lunch. And then on Sunday, there's a trip to Fire Island National Seashore. That's sort of a not quite an annual event, but it's New York State's only national park. It's a trip that's organized in conjunction with several groups. You have to take a ferry, you cannot take a car to Long Island. So I think you all got an email about that. So there are free tickets to give away, first come, first served. See me again for more information. That's on the Sunday the 24th. Thank you.
All right. Thanks, Malcolm. And I'm going to invite Kate up here to introduce our speaker today.
Thanks. Really pleased to welcome Reuben Kline, our speaker today. As you can see, Reuben's in the Department of Political Science. He's an associate professor there and is also the director for the Center of Behavioral Political Economy. Reuben got his PhD in political science at the University of California. He has 3 master's degrees, which I won't, for a number of fields. So
shouldn't do that. Yeah.
Okay.
Not a good idea.
Barcelona, that was probably a fun time.
Yeah, that was good. Yes, that was good. Yeah. I did
Reuben's interested in an affiliate appointment in SoMAS. He's been involved in things in the SoMAS sphere over the past several years. He was part of discussions for Inspires. He's served on a search committee. Thank you very much. And I think he's also, is collaborating with SoMAS folks already on some funding proposals. Reuben's going to be on his title today, as you can read it. And this is drawing upon work in a forthcoming book, Climate Change Experiments in How People Prevent Disaster. And Reuben publishes in Political Science Journal, has also published several things in Nature Climate Change. So there's lots of overlaps that we'll be excited to learn more about.
Okay. Okay. Hello, everybody. Thanks for coming. So thanks, Kate, for the introduction. So I'll first apologize. So I made this title as broad as possible to bait people into coming here. So it'll be a little bit more narrow, the actual studies that I'm going to talk about. But what I want to try to get across is that I think this approach that I'll be talking about, kind of experimental economics, can hopefully be something that could be valuable for potential collaborations with people in SoMAS. And so I'll talk a little bit about that. So as you probably know, climate change is a global social dilemma. So what social scientists mean by social dilemma is any situation in which sort of a individual short-term interests are at odds with what's best for the group in the long term, right? And so the development and deployment of new technology, probably also, is sort of crucial, right, for solving the climate crisis. But what I'm going to talk about today is that the sort of development and deployment of these technologies itself is subject to some of the same social dilemma dynamics that sort of complicate solving the underlying problem. So let me first talk about the experimental economic gains, right? So games isn't meant to mean that it's unserious, right? Or that it doesn't matter. Games is meant to invoke the idea that it's about strategic interaction, right? That's what we mean by games, right? So when we do economic games in the laboratory, right? So laboratory is just in our case, bunch of computers in a room over on the other side of campus. But so we could sort of create a hypothetical world. We create this world in which the incentives are created by us, the outcomes are known by us, and they're known by all the people participating, right? And these are sort of stylized representations. So as in any theory or model, right, it's a simplification, right? So I'm not used to presenting this in front of people who know a lot about these climate technologies and stuff. So I'll try to be careful, but I still might be wrong about that stuff. But certainly I will oversimplify things, right? In many cases, right? But and you can correct me where I go too far off the range, right? So, but one nice thing here is, right, so there are potential climate technologies that don't yet exist, but it would be nice to know how people might strategically respond to them if they were to exist, right? But by the time they actually do exist, maybe then that's too late. So this can give us a little bit of a handle, right, on what people might do, right? Again, okay, so the other thing is we know the material incentives. So one thing about experimental economics is that we pay people money to make their decisions, right? We don't just say, you come in here and we'll give you $20, right? The amount of money you get depends on the decisions you make. And in these kind of games, the decisions other people make, because your outcomes are interdependent. That's why it's strategic, right? And so that's great. That helps us measure people's choices, right? So because people care about money, right, as we know, but people care about other stuff too. And we can see in these games that people give up money for other things that they value, right? Or we assume they value these other things because they give up money to get them. Right? Okay, so and it also allows us, because we randomly assign conditions and stuff, helps us get some handle on sort of the causal mechanisms underlying that. And in social science, that's challenging. Okay, so the downside is, as I often hear from peer reviewers, right, is something that social scientists call external validity, right? So that is, okay, how does this sort of hypothetical world you made, how well does it map onto the real world problem you're trying to represent, right? And yeah, so a lot of people do not too well. I disagree, right? So, but some of the reviewers are less kind, as you know. So I'm going to be talking today about a particular paradigm. So originally it was called the collective risk social dilemma. This is, I meant to put that in there for you, but that's kind of a long name, not that marketable. So we've started calling it the disaster game, right? So which is a little bit of a more marketable term, we hope. So it's a public good, threshold public good game of loss avoidance. Okay, so you probably don't know what any of those terms mean yet, so I'll explain, right? So the public good is just something that's non-rivalrous, meaning that if I get it, it doesn't prevent you from getting it as well, right? And non-excludable, right? That once it exists, everybody can enjoy it, right? So that's one of the strongest examples. I mean, climate change is one, or preventing climate change is one, but a lighthouse is also a really good example, right? Because once the lighthouse exists, whether you paid for it or not, or whether you did anything, you can bring it into existence, it's there, every ship can see it, no matter how many ships are out there, they can all see the lighthouse, right? So it's non-rivalrous and non-exclusive. So that's a public good. So a threshold public goods game is just where the group needs to contribute money to a common pot to reach a certain threshold, right? So in these games, people in small groups, they're typically 4 to 6, right? Just to make it a little more manageable, start with a given amount of wealth that we give them, right? And then a portion of their wealth can then be contributed towards a threshold value, right? That they're all contributing towards or can contribute, right? So if the group's collective contributions meet this threshold, right, or exceed this threshold, then the group avoids a collective risk, right? A disaster, right? Basically losing all of the money that they didn't contribute, right? If they fail to meet the threshold, right? And this is so if they meet or exceed it, if they meet the threshold, then they avoid the disaster, right? And they keep the rest of their money, right? So you can see that everybody has an incentive, right, to say, hey, great, I don't want the disaster to happen, but how about you pay for it, right? and then I'd be better off because I get to keep all my money, right? So that's the social dilemma sort of part, right? And typically, although not always, the loss, if they fail to meet the threshold, the loss is probabilistic, set some percent, some probability, right? Though sometimes it's just with 100% probability, 100% chance. Okay, so that's the basic idea. So here's just the thing. So the original game that was said, the people were German, so these should maybe be euros instead of dollars. But so they each had $40. There were 6 of them, so 40 euros. There were 6 of them, right? So collectively they had 240 euros. If they contributed at least 120 euros, then they would avert the disaster, right? This thing isn't quite adding up to the right numbers here, but they were basically half of their endowment. That's half of their wealth. Okay, then they would avert the disaster. And if they don't, then if they fail to meet the threshold, right, and don't contribute enough, then whatever the original likelihood of disaster was will remain, and they might lose all of their money. So sorry, I should say, right, feel free to interrupt, right? So I know norms differ across disciplines. In economics, I would have already been interrupted like 12 times now. So you're free to interrupt, right? So go ahead, right? In political science, people usually hold up to the end, but if you want to ask anything, please. Okay, so that's the basic setup, right? And so what did the original guys do? This Malinsky. So they just manipulated this probability of disaster, right? So if you don't meet the threshold, how likely are you to lose your earnings, right? They set it at 0.1, 0.5, and 0.9. Probably not surprising when it was 0.1, very low likelihood. There wasn't really much of an incentive to contribute, right? So literally none of the groups contributed enough to meet the threshold. In the 0.9 condition, half of them did, which is still maybe half as few as we would like it to be, but still a big increase, right? Because now, like if they don't meet the threshold, almost certainly they're going to lose everything. So there's a big incentive to miss. So that was the original paper, originally published in PNAS back in 2007. So we wrote a whole book, basically, that's finally, first time I've ever published a book, and it's taken, half of my life or something, but finally it's going to come out in March. It's with my colleague Andy Felton, who's also in the Department of Science at Albert. Andrews is a former student who is, if you're hiring somebody in SoMAS to do this stuff, you should hire her because she's amazing. Anyway, so she's not at the University of Connecticut, but she's great. So we wrote a whole book about basically extending this disaster gains with many of our own studies and some other people's studies, right? And so here I want to talk about 2 studies that are about the effect of new climate technologies on people's willingness to sacrifice to avert climate change, right? Okay, so one way of thinking about sort of new technologies, right? There's a gross oversimplification, is that you have some technologies that you sort of more or less we know if we put $1 into that, how much emissions reductions we're going to get. Right now, of course, these are solar panels. Obviously, that's been increasing and better than most people had expected and keep exceeding expectations. But so this is an oversimplification, but the idea is that there are some technologies that more or less if you put in $1, how much reduction you're going to get, right? How closer to the threshold you're going to be, right? There's other technologies like say carbon capture or something. So this is a mangrove tree, but maybe not some kind of tree. So it does capture carbon, right? But as you know, there's these ideas to capture carbon on like an industrial scale, but as yet, of course, not clear whether that will be feasible or technically feasible or economically sort of, make sense economically, right? So, okay. So that's sort of what we're trying to capture here, right? So our question is, right, as disastrous climate change becomes more costly to avert, will people be more willing to invest in this sort of unproven but potentially very effective climate technology, right? And so it's in the book, but it's also published in a paper that we published a few years ago there in Nature Climate Change. So what did we do? Well, we added to this standard thing, right? So in the standard thing, you can either give some money towards the threshold, so we can call it a contribution or cooperate in the social dilemma. Typically, when you don't cooperate, you're called defect in the social. That's what they call it typically. So we saw those 2 options, but we added a third option. So this third option is like a risky contribution, right? So it's a kind of roll of the dice, right? So now in a certain contribution, you contribute $1 as a standard, you get $1 closer to the threshold. In this, with the risky contribution, now you contribute $1, there's a 50% chance doesn't do anything, and there's a 50% chance that it gets you $2 closer to the threshold, right? So economists would say that gives it the same expected value, right? On average, it's $1, right? But sometimes you'll get $2, sometimes you'll get $0, right? But if you did it thousands of times, you should expect to get, $1 on average, right? Okay. So that's what we added, right? Just a small little wrinkle here. So what we did was then we manipulated, right? Keeping the group's collective wealth constant, right? The initial amount of money we give them. We then manipulated, right? We changed, we had different groups face different levels of the threshold, right? Okay, and so basically just to talk about the results quickly, right? So basically the willingness to make risky contributions increased as the threshold increased, right? Defecting, right? The non-contribution sort of remained flat. So really what they did was they substituted at the higher thresholds the risky contributions for the certain contributions for the risky contributions, right? So one kind of cool thing about this paper, I think that made it appealing maybe to the people in nature climate change, was that it also had, unlike some of these other papers, had a really strong theoretical, or we think very strong theoretical foundation in evolutionary biology. So I don't really have time to get into it, but there's something called risk-sensitive foraging theory, which was originally applied to birds. But then it's been extended to sort of the evolutionary psychology of humans, right? And humans do have seem to have a similar evolved psychology, right? And it just means when you're really desperate, you're willing to seek out higher variance sort of food sources. Well, that's what the birds want, right? So this is similar, right? If you're desperate, it's like, okay, even if it's not going to work, it's the only thing that's going to save us, right? So we did this. As far as we know, it's been extended to humans, but this is the first time it's been used in a sort of strategic setting, we think. Okay, so we ran actually 4 different studies, right? So just let me quickly walk you through here. So there's 2 different things here. There's the lab, right? So that's students here in SDS, right? And then online is this online sort of labor market thing. They call it Mechanical Turk. It's run like everything else by Amazon. That's a common behavioral researchers use a lot. This is a quick way of getting sort of pretty cheap and quick data, right? So these are 2 different samples of people. And then the high stakes, right? So there's another little wrinkle in here that instead of just having one pot of money that we gave them at the beginning, we gave them sort of one pot of money that was illiquid, meaning they couldn't contribute it, and then another pot of money that they could contribute, right? So obviously, if you've got a big pot of money that's also going to get wiped out if disaster happens, that gives you a higher, bigger reason to contribute, right? Because you don't want to lose. So this is supposed to a little bit simulate the idea that, wealthy countries have a lot of very valuable infrastructure and stuff that should make them give them more reasons to want to mitigate climate change, though maybe that's not what's actually happening, but that there's at least a logic, right? So the high stakes is just that they got twice as much of this illiquid funds, right, to protect, right? So because we thought maybe, we ran an originally with the low stakes, and maybe it's they're just like there's such a strong incentive to contribute because so they did, right? So or we ran first with the high stakes. So then we did it with the low stakes. The results are roughly the same. So what really matters is that, so here's the threshold, right? 60, 80, 100, 120, 140, right? So what really matters is that the first 2 thresholds, because they could each spend up to 20 of them, right? And there's 4. The first 2 thresholds can be met without any risky contributions, right? If all 4 people contribute 20, then you get 80 and you meet the threshold. All the rest of them require someone at least to make the risky contribution and have it pay off. Right, because you can't get to 100 by just adding up 4 20s, right? That's so you need at least one person to gamble and have them pay off, and then you can get to 100, right? And so really, what we're comparing is that we think that these black bars should be the first 2 black bars should be small, meaning not many risky contributions, and the last 3 should be bigger, right? And generally, that's what we do see, right? So it's a little bit complicated about the combinatorics of who has to contribute or who makes the risky contribution. So actually, the game theory said that the fifth one should actually be lower than and the fourth one, and that's actually, we see that quite a bit. But the main point is the pattern is the same, right? So hash lines are the defection, right? Remain more or less constant. What we see is that there's a switch. So the black bars are small here and big here. The white bars are small, big here and small here. That's what we sort of expected, right? Because at the 100 and above, somebody has to gamble. Otherwise, it's not gonna, you can't possibly solve the problem, right? Okay, so that's the first study. Yes, yeah,
Can I take your invitation to interrupt?
please.
Is this, I might have missed, is this cooperative or is this like a prisoner's dilemma?
Well, it is, so it's a form, so all social dilemmas are kind of like a prisoner's dilemma. So the prisoner's dilemma is the one where you should expect the least cooperation, because basically game theory said that everybody should defect all the time. Although that's not what actually happens when people do, but that is what the game theory said. This is not quite as perverse, because there are some equilibrium in this game where there are cooperatives. Basically, any set of contributions that exactly meet the threshold is a Nash equilibrium. If you've ever heard of game theory, then that's what you learned about Nash equilibrium. So any set of, but so is zero contribution. Zero contribution by everybody is also a Nash equilibrium. So, but at least here there's sort of pro-social equilibrium where you can actually solve the problem and have it be a Nash equilibrium. So there's actually any one that exactly meets any combination of contributions that exactly meets the threshold is an Nash equilibrium, because that means that nobody, given that everybody else is what they're doing, nobody wants to change. That's sort of what Nash equilibrium is, right? Okay, but yeah, good question. So the idea is we want people to cooperate, right? But the social limit setup is that, well, they have reasons not to. Yeah. So we're kind of seeing the factors that make it more likely that they cooperate. That's sort of the goal of all of this stuff.
That's the follow-up question.
Yeah, of course.
Do the participants in this communicate with each other?
Yeah, so really good question. In our studies, no, but that's a great question because there are tons of studies where they do. So the baseline is that people don't cooperate, right? So they're just making their sort of guessing, right, about what other people will do. There are many experiments where people can communicate, and I think without exception, that increases cooperation. Without exception, and it depends on the kind. The more face-to-face it is, the better, right? But so Eleanor Ostrom, who you may have heard of because she's kind of a sustainability person that does this kind of stuff, did this kind of stuff, won the Nobel Prize in economics, so not an economist, political scientist. But so she studied a lot of that stuff, and both in kind of lab stuff like this, and also going into real world kind of comical resource stuff, and looked at the way people communicate. So that. Almost without exception, so there's some meta-analyses and stuff that show that like pretty much it always increases cooperation. But in our case, which is kind of the standard baseline one, there is no cooperation, communication, right? And so these people had to guess, right, at these higher levels. It's like, well, I know somebody needs to take the risk, right? But it might, in some cases, it's better if some people take the risk and some people do the certain contribution, but they had no way of coordinating that, right? They just had to sort of do their best guess, right? Yeah. Yeah.
So I understand there have been, from what I remember, there have been studies that pull cooperation based on sort of, I guess, the lack of communication, but then the participants are informed that there is, I don't know, like 80% of other subjects did the thing that they're.
Oh yeah, sure.
So if you apply that to this, then you expect to see an inverse effect, since the participants are getting the information that, oh, other people are already taking the risky behavior.
Oh.
I don't have to.
Yes, possibly, right? So yes, so there's some coordination involved, right? So some of the equilibrium involved like two people, taking the risky thing, but that only works if two people do the certain thing or something, right? So yes, and you're exactly right. So this when they tell people that like 80% of previous people cooperated or whatever, this is sort of setting a kind of normative benchmark, right? And that helps in these situations because most people are sort of what they call conditional cooperators, right? They're happy to contribute as long as they think other people are going to. If they aren't, then they feel like a sucker, right? They're like, I'm the only idiot that's doing this, and these other people are free, right? So this is a very strong thing. In a lot of these experiments, they'll like create behavioral types based on people's behaviors. When they do that, almost always, most of the people are conditional cooperators. You have some people who always defect, some people always cooperate. Most people are sort of conditional cooperators, right? So this sort of messaging kind of helps people sort of reduces their fears of being a sucker, right? you get the suckers payoff, they actually call it that, when you are the only one who's cooperating and everybody else is good back. Yeah, so but good question, yeah, so there's a ton of other things, right? So that's what's cool about these experiments is that anything you ask me, almost, we can build it into this thing, but we kind of have to do it incrementally, because the whole point about experiments is that you do two things, they're exactly the same except for one difference, or you try to make it that way. It's almost impossible to actually do that, but that's the idea. So then you build in one difference, and then you do a slightly different version, and so you can build up all this stuff, though it takes some time, but yes, so all of these things can be built into this game, right? Potentially, maybe not all at the same time, but second. Okay, so yeah, great questions. All right, so get higher mitigation thresholds, increase risk taking, yes, and in a way that consistent with game theory and risk sensitive foraging theory and all that kind of stuff. The one reviewer was incredibly excited about this risk sensitive foraging theory, like went into great detail about the original study on juncos or something, some kind of yeah. Okay, all right, so another way of thinking about technological progress and climate change is thinking about sort of magic bullet solutions, right? Silver bullet solutions. Okay, so like geoengineering or something, right? Or maybe carbon capture, things that are going to just like solve the problem for us or something, right? And so, there's a lot of different headlines, right? So here's one, climate policy, this, so the world could turn to this desperate final game, talking about, geoengineering, I think it's solar radiation management probably. Okay, and then these two are talking about like carbon capture, right? Carbon capture could save the planet, right? Okay, great. All right, so here's the problem. So economists and other people worry about this thing called moral hazard, right? So this comes from the economics of insurance, right? So the idea is that like if I get really good health insurance and really good fire insurance, then I'm going to sit at home all day, smoking cigarettes or something, right? The idea is that if you reduce a risk, right, then you might be more risk taking. Okay, so that's the idea, right? Psychologists often call a similar idea risk compensation, and there's some debate. Some people say that this whole thing with climate isn't really moral hazard; it's risk compensation. That's just sort of semantics, I think. But anyway, so it's possible, right, that if we introduce these kind of silver bullet solutions, right, that might actually potentially kind of backfire, right? And if people think it's like, oh well, you just have to put some sulfur up there in the stratosphere, and then cool, I don't have to do anything, right? So great. So that's what people are worried about, right? Especially elites, right? And so there are discussions by elites, right? Like so academics, policymakers, and stuff that are like, we can't even talk about this stuff. We shouldn't even talk about it because it's going to make people think that we've already got the problem solved and we don't need to worry about it, right? So okay, but is that really true? So we're interested in this question, right? So there's quite a few studies, well, maybe not as many as there should be, probably we've seen some now, but a lot of these are like survey experiments. So they have to at least initially introduce the idea. So most of them are about solar radiation management stuff, right? So first they have to introduce the idea to survey respondents, because most people have no idea that this is even a thing, right? Or what it is. But none of these studies find any evidence that people would engage in moral hazard. In fact, I think it's Merck et al. I might be wrong, I can't remember which one. I think it's that one. That once they describe the idea of stratospheric aerosol injection to these people, they're like, holy crap, that's what it's going to come to if we don't do it. And they actually have more support for mitigation. So it's like the opposite, right? So anyway, so despite the logic of this moral hazard argument, right? It is the evidence that it would be a thing is relatively weak, right? So our interest is if the public perceived that technology could provide a silver bullet to stop climate change, would they be less likely to invest in climate mitigation, right? So that's the moral hazard problem. But there's a second issue that nobody else, I think, has explored, right? And this is, so the elites anticipate this moral hazard and be more reluctant to deploy these technologies, right? And so again, anecdotally, right, there are discussions amongst elites about exactly that, right? That we shouldn't do it, we shouldn't even talk about it, right? Okay, and so this is from something we recently published in the Ecological Economics, it's an economics journal, but yeah. So Okay, so, right, so again, just the basics, disaster game is that, okay, we got this climate threshold, now we got 4 people instead of 6, okay? They each got, 100 tokens. Climate threshold is 160 tokens. Okay, so if they only get 140, not good enough, they lose everything. Okay, bye-bye. Okay, now they get 160, great, they keep everything. So that's the standard thing. So what did we do differently here? So we got these 4 players, each got their bag of money there, right? 100 tokens. And so we do these tokens thing, and then you just convert it to actual money at the end, but they know how much like a token is worth, right? Okay, so what we did was we added another player, right? I believe in the actual experimental instructions, we called it the mayor, right? I think in the paper we called it the policy maker, right? But a separate person, right? So they have 50 tokens. So you may ask why 50 tokens instead of 100? Well, because they can't contribute to the threshold, right? But if the threshold isn't met and climate change happens, the disaster happens, then they lose their 50 tokens. So they're in, they have, they're also subject to this collective risk as well as the people, right? And so we wanted, given that, these people can contribute, right? We wanted, like, if they successfully contribute, that they kind of make this more or less the same activity, right? So there's not some kind of inequality aversion that's driving people's behavior, right? So that's something you have to worry about, like in these things that people don't like unequal payments, well, especially when they're on the less side, right? The lower side, right? Okay, so we introduced this person. So what does this leader do? Well, this leader can pull a lever and do stratospheric aerosol injection, right? Whatever, yeah, some kind of geoengineering, right? That's how we describe it in the thing, right? So you strand sulfur up there, right? Okay, so if that works, right? So just to bounce ahead for a second, what we manipulated in this was the probability that this works, right? That geoengineering works. So if it works, right, then no matter how much they contributed, problem solved. Threshold is met, they don't lose their money, right?
When you talk about dollars and euros and money, you mean that in the literal sense?
I mean that in the literal sense. So these people will get money, cash money paid to them when they need the.
So why would you or I donate money? Who would be donated to? I mean.
Oh, so they keep the money, right? So some of these, so you're talking about maybe the money that goes to they contribute to the threshold or something, right? So
you're talking about increased taxes. What are these contributions?
What are they supposed to represent? I see. Yeah. I think you can think about it as like kind of increased taxes, maybe willingness to pay for upgrades or something, buy heat pumps, stuff like that, or something, right? So it could be a number of different things. Again, oversimplified here.
But those things, one is forced on your taxes, the other is voluntary.
Sure. Although they tried to do it in Germany to make it forced, and that didn't work. They tried to make it so new buildings
People
had
tell
that.
me every day to put solar panels on my roof.
Yeah.
I get 6 phone calls a day. But I made the mistake of answering an S. So that's a voluntary thing on my part, right?
Yeah. Right. So and of course here this is voluntary, right? So nobody's taxing them. I mean, we could say, we're forcing this money from you or whatever, right? But we're interested in sort of understanding people's willingness to do something like this, right? Which I guess we would say if they're willing to do it here, might mean that they're willing to support a tax to do it in the real life or something, right?
Motivation.
Whoops. Okay, anybody? I'm not sure. I didn't do that.
Actually.
I don't think it's because it still shows.
Okay,
Yeah.
so.
Just click on the back.
Yeah.
Okay, all right, good.
Don't worry.
All right, perfect. Yep, good. All right, so again, so this is you're hitting on exactly, some of the external validity concerns, right, that they have, right? So what does this really mean in the real world, right? And so, we would argue, or I am arguing, I guess, that it is just sort of a measure of people's willingness to sort of sacrifice for this. Yes, in this particular context. Right? So does it exactly map onto what's happening in the real world? Not exactly, but hopefully it's somehow related to that, right? Is what I'm saying. And so I should say that that's a good point. So in some of these games, so not the ones we did here, but the original game. So when people contributed the money, they actually bought carbon offsets, which arguably didn't do anything to help with the money that they did. I think there's, yeah, no, it's Germany. So in the EU carbon market, they bought EU carbon credits or something like that, I think, with that money. So that makes it a little more real world. So the money they're actually doing is actually, at least potentially, reducing climate change, right? Though that's not what we did in these studies, right? But you can do that.
When are the persons contributing at the same time?
Yes.
Or at the same time?
So at the same time, right? So that's related to his question about communication,
So
right?
they're not even taking turns or anything like that?
No, well, so it depends. So I've oversimplified a bunch of stuff here just because I don't have, so it depends. So some of the studies, there's multiple rounds. So then you can sort of see what people did in the previous round and condition your behavior on what they did, right? And then at the end of the 10 rounds, is when you need to meet the threshold. That's the original study. Many of the follow-up ones, we've done some like that for, I'm going to say largely for kind of statistical power reasons, right? So then when you have groups and their choices are interdependent, right, then you lose statistical power because they're not independent, right? And so we do one-shot choices, so that way each one of the people's decisions is statistically independent. So I don't know, that's a good reason, but that's the reason that we do, right? So these are just single shot, right? They just do it one time, but simultaneously and without communicating. Yeah. Okay, so they don't make it, right? Okay, so then yeah, doesn't work, then they lose it. All right, so with probability of success, right? So we manipulated the probability of geoengineering working 10, 30, 50, 70, and 90%, right? So different people saw different versions of that, right? And I should say here too that, so of course, as I'm sure all of you are aware, nobody really knows what would happen if we did solar radiation management. Seems like from the volcanic eruptions and stuff, it probably would cool the earth, but it might do a bunch of other bad stuff too. Nobody's really sure, right? So none of that is here, right? There is no down in this game, right? And again, we know this because we designed it this way. There is no possible downside to using geoengineering. Not realistic, maybe, but it makes it should make moral hazard even more likely to happen, because if there's no downside and you know it's going to work, well, or if you think it's highly going to work, then you shouldn't contribute anything, right? Like if you're just trying to make as much money, right? So there is no downside, only upside, right? Okay, again, not realistic, but it helps us understand people's motivation or isolate people's motivation, right? So just to sort of recap here, right? So and add a little bit more information. So at the start of the game, a disaster is coming that's going to cost 160 tokens to stop. Okay, the 160 tokens doesn't really matter. It's just the way the game was parameterized here, right? And then this policymaker can choose whether to implement the silver bullet, right? Knowing that the probability exceeds. So the policymaker knows whether it's 10% chance of succeeding, 30%, whatever. They know the percentage, right? The citizens then decide whether and how much to contribute, knowing only whether or not they use geoengineering, right? And the sort of range of probabilities, right? They know it's either 10, 30, 50, 70, or 90, but they don't know which one. They know that the leader used it or didn't, and they know the possible likelihoods of success, okay? So, but they don't know the actual, success rate, success probability that applies in that particular situation. Like they just know the range. Okay, so if that's the case, then we should see, right, that when they're told that the geoengineering was used, right? So that's over here on the there's a pointer here, I guess, right? Yeah. So over here, right, when geoengineering was used, right, if there's moral hazard, they shouldn't contribute as much. Here, geoengineering wasn't used, and yes, there was a slight reduction in, so like maybe from 40 to 38 or something, right? But it's not really, certainly not statistically significant and not really substantively significant either. So there was slightly less contribution, but very, very slight, right? Okay, so that's the sort of standard argument that like, okay, people are gonna just think they got a free lunch and keep, burning coal and eating beef or whatever, right? But, okay, so again, like, consistent with previous studies, right, we don't really find much evidence. But the perhaps more interesting thing is, so here is what the proportion of leaders, policymakers, mayors, whatever, we're using 3 different terms. The people that can actually pull the geoengineering lever, right? So here's what they did, the proportions that they, actually did, right? So not surprisingly, when it's 90% successful, I think it was 99% of them use it or something, right? And you see it gradually goes down. Makes sense. But only here, right? So it only could have helped. It only could have helped them here, right? And so the only reason for them not to use it is because they think that if the citizens are told they use it, that they won't contribute enough to meet the threshold. And so they don't use it at the low values, only when it's a high, right? And again, the citizens don't know which of these percentages is actually accurate, right? So they might think, oh, well, it's going to be the 90% one or something, right? When it's actually the 10% one. So that's why you see these drop-offs, right? But again, they're anticipating that there will be moral hazard, right? It would seem from this, right? But there isn't actually any evidence of that. And the even more remarkable thing about that is that the way we set up the game was first people were leaders and then they were citizens. And so these same leaders who thought citizens would be subject to moral hazard were not in fact subject to moral hazard when they were citizens, right? And so that's interesting, I guess. Okay, so we call that anticipating moral hazard or something, anticipatory moral hazard, something. So do silver bullets cause moral hazard? Well, not really, but policymakers do seem to anticipate a moral hazard, right? Now, again, in our data in this game, it's important to make those caveats, right? So who knows, right? Again, this isn't real world geoengineering, so we don't know. But again, when real world geoengineering happens, if it does, that's super high stakes, right? So hopefully when we're in that position, we'll know a little bit about how people might respond to it, right? And so these kind of studies we think can help. Okay, so I guess that's all I've got. Let me just say one thing, last thing about, I was talking to Adam earlier, and so he asked, he's like, well, do you ever run these things with like, not students or not? And so I haven't really, but people do, right? And in one case, it more so in another kind of social dilemma called a common pool resource dilemma, right? So these are common pool resources are like fisheries and forests and things like this, right? Also the atmosphere is a common pool resource. So there have been lots of studies. We talked about one in our book that we didn't do, one about that works with abalone fishers in Baja California in Mexico, right? And so they actually use people who are abalone fishers by day, right? And they tried to construct sort of the strategic environment that they face in the lab, and because they had recently been granted sort of autonomy sort of over certain zones, these kind of cooperatives that they had or something by the Mexican government. And so they wanted to see how they would kind of govern these things against like poachers and stuff like that, right? So they set it up to sort of all the parameters and stuff to sort of mirror their earnings and things like that they would make from abalone fishing, right? And it gives it more external validity, right? So I think there's scope for doing something like that, with giving stuff that so much people do and combining it with this kind of stuff, right? So that was the pitch I was doing. So anyway, so thank you very much for your attention. Yeah.
Do you or other folks ever like focus group this afterwards to try to get more qualitative understanding? Why?
Well, I wouldn't go so far as to say it's a focus group. So usually what we do is ask them for like open-ended comments, right? And so as you might not be surprised by, some people write nothing, and some people are there like in the lab. Everybody's waiting because nobody can go until I resign. You got somebody like typing like 500,000 words or something. So there's a wide range of things, right? So we've never done anything so systematic as a focus group, right? But so I've got this. Hold on. So here, so these Mechanical Turk people. So here's some nice comments from Mechanical Turk people, right? So So this one is good, where is it? The one, oh yes, where I get the huge checks. So I'll take, please hand me the huge checks as I walk out the door. Yeah, so, yeah. So, but the funny thing is, so Talbot, a former student, so she's amazing in many ways, and so she just sort of, out of curiosity, took these and coded them up to see, coded them as climate deniers, right? Somebody, based on these comments. And so the funny thing is, right, and I'm not sure if this is good or bad news for this methodology, but there is no difference in the way climate deniers behave in these games and the normal people, right? And some of these even said, it's like, I know that climate change is, BS, but, I wanted to make money, so that's why I contributed to the thing, because I didn't want to lose all my money or something, right? So that gets, that might reduce, that gets at the external validity and stuff of it, whatever. But yeah, so we probably should do more of the focus grouping stuff, right? Part of the problem is we've already got people there for some time. Typically economists want to pay them their opportunity costs. So the more you keep them there, the more you need to pay them and whatever. We keep getting our grants rejected, so yeah, can't say keep track. But yeah, so yeah, but probably there should be more of this kind of iterative process of kind of getting qualitative stuff to then inform new studies, right? And we don't do enough of that, I think. Or, yeah.
On the slide where you were talking about the results of what happened with the percentages and the errors and the engineering.
Yeah, this one.
Did they ever hit the threshold? Because I noticed that the tokens for both and that's per person.
Oh, so this is contributions of tokens. So yes, I don't.
I thought that was tokens.
Yeah, so it is. So it's contributions of tokens. So
Okay.
so on average,
It's
no.
40, but they would need 60
One.
each person, right?
So yes, so they would need. So it was 160. So they would need. So this is, I believe,
Oh, that's
this is per person.
Okay.
So they no, that can't be right.
People donated exactly what they needed on it.
No, this might be per group. Sorry, I should know that. But I don't recall because I don't have it on this slide. So I don't remember, but some of them met the threshold and some of them did. That I'm sure. But what the relative proportions, I don't know. Yeah, that's a good question. I didn't even think about what that actually. So that's a terrible practice, by the way. So for all the students, that's a terrible job. You definitely know what the data is. But so sorry.
Per person would be exactly what they needed. Is why I would-
Yeah, 40 per person would be exactly what they needed. And so this is of course an average. So some would fall below that and some above that, but what is an average of, I don't. So maybe it is. I seriously doubt it's per person because typically they aren't that successful at that. I'll look at, yeah, that I should, yeah, I guess.
In these models, do they ever consider other demographic factors of the participant?
Sure. So we do, we collect that information. Typically, it doesn't yield much. So of course, political scientists always ask, well, did you collect party ID and all that kind of stuff? Yes, of course. So with students, you don't get a whole lot of variation on that stuff is part of the problem. Inter gives you more variation, though it's not like a representative sample either. They certainly have more conservatives than a standard college student sample would have, but they're also kind of weirdish conservatives that do Inter, I think. So yes, we do collect other data. So, but oftentimes it doesn't really matter. Part of the benefit of experiments is that if random assignment sort of works, right, then the two groups should be sort of on average the same on these demographics. So of course, any given randomization doesn't necessarily mean that was the case, but you can do kind of covariate balance tests and stuff to see. So it shouldn't affect the results, right? The differences in the treatments, right? But still sometimes, yes, there are, we look at that stuff, but typically that's not our focus and typically it doesn't really give us much. But yes, we
So I'm wondering in the application of this, who would be the players of this game? Because as you've already established, you have your sort of elite of the academics, the policymakers, the big financial players,
Right.
who they're the ones who are worried that people will fall for the silver bullets, but they
Yeah.
are also the ones who are most likely to contribute. And then you have
Probably,
the
yeah.
majority of middling America or elsewhere, really, that might not actually have the liquidable assets to contribute in the first place. So
Right.
who then is the subject?
Yeah, so, you sure you guys weren't peer reviewers on that? Yeah, no, I'm just kidding. So, no, very good. No, so, yeah, that's a good question. It's not clear, right? So I guess it is the short answer, right? So. Especially when some of these papers, including some of my own, like try to make it seem like it's about like international climate negotiations or something, then people get really worked up about it because they're like, well, these are college students, they're not international climate negotiators. So I would note that most international climate change negotiators were at some point college students. So I guess. So anyway, but yeah, so it's not clear exactly. I mean, so some like psychologists or something will say, well, we're looking at sort of universal, there's some universal component to human behavior. And so, yeah, but of course, much human behavior is contingent on your social position and various other factors. So of course, you're right. So the answer is I'm not sure, right? So I guess I'm gonna fall back on the psychology thing that we're kind of trying to look at like general ways people live. So that's maybe honest. Oh, yeah, so yeah, John?
So I was wondering if like the whole podcast is some sort of potential valuation thing, like where we test the willingness of people to pay for an environmental value.
Yeah, I mean, so that's another thing that experimental economists do, right? They do the contingent evaluation. I've never done one of those myself, but yeah, yeah, I mean, in some ways, I mean, it doesn't. Yes, but I would note not in absolute values, but sort of in relative terms, like sort of like what makes us value this more or less, right? But I don't think you can really say that they value it at like contingent valuations. You're like, well, am willing to pay $1,500 to have a park or something, right? So it's not quite that precise, I guess, right? But it kind of is measuring a similar kind of willingness to make these trade-offs. Here would be about like the trade-offs that people are willing to make. I guess, right, more so. But yeah, I wouldn't say you could put it that any of these methods would allow you to put an exact dollar figure on it.
Like, can we use the results for when we use like carbon I don't know exactly like that, but then we're like trying to put the carbon cap on certain kind of industries or
Sure.
industries. Can we use the start to assess the behavior of a particular socio-economic group or how they're behaving to calculate the amount they're willing to pay for?
Sure, yeah, I think so. Yeah, you could. I mean, that wasn't really the objective here, but yes, I think you could design studies that do that. Yes, absolutely. Yeah. Yeah. Yes, there, yeah.
Thank you for coming to SoMAS
Sure,
first.
sure.
For having me here. This is climate and mitigation or hazard question that we have, but with disasters, natural hazard induced disasters, let's say floods, let's say hurricane, but flood would be easiest to relate to. We know that moral hazard is a very real thing with those. We know that millions of American population lives where they do because of that silver bullet that is not as fancy as your geoengineering, but it's just a simple living.
Yeah,
You know,
insurance,
so much-
because they're insured. Well, that's increasingly not the case.
Because of that.
Yes.
So how would this experiment
Mhm.
either be reconciled or how would you design a different versions of this to try to understand that in an experimental environment?
Yeah, so you definitely could. I haven't done that, but yes, you could. So you could, I mean, yes, so you could sort of see, I'm not sure if it would be honestly that different, right? I mean, you might frame it a little bit different, like in the instructions and stuff. We talk about, well, this is your house, and are you willing to rebuild? I mean, I guess you have to think about what question you're trying to ask, because then that would determine like what kind of experimental manipulations you'd want to make, right? But definitely.
What would you expect to find from that? Some might be or not.
I think so. I mean, well, if there's anything like the real world, then there's a bunch of moral hazard in this kind of, whatever you call it, residence choosing or whatever.
Yeah, but also policy.
Yeah, sure. Yeah. Yeah. So I'm not sure in the abstract what I would say. I think you would probably see moral hazard there, maybe, I don't know, but then if it's exactly like this setup, then maybe not, because we didn't see it here, right? So I feel it's gonna be interesting to find out. Yeah.
How do you expect your results to change if you introduce downsides to the silver bullet?
Right, so, I mean. That's a good question. I mean, I guess you would expect to see policymakers using it even less, right? And perhaps I would expect you wouldn't see, that wouldn't cause moral hazard to happen, right? It seems like it'd be less likely to take that if there was downside, right? But short answer is I don't know, but I mean, we were trying to set it up to make sort of the best case for this thing, right? And then still we see that, you know, there isn't this moral hazard, right? So, but yes, yeah, so. There was one back, yeah, huh?
So it's really heartening to see that people are like still going for contributing even with the silver bullet, but
Mhm.
my fear is there's just so much money behind like the oil and gas industry that is so invested in spreading disinformation about all of this that in the real world, do you think it would play out that way, or do you think that over time it would just kind of erode people's interest in actually taking it seriously?
Well, I don't know. I mean, I guess all I can say is what's happening in the real world now, and I think it's less heartening than this experiment would have us believe. But I mean, you know, so I don't know what oil companies' stances are on geoengineering, but perhaps they like it because of this idea. Because they're like, well, then nobody's gonna just like, you know, they are investing, you know, there's that forget the actual term for it, but the carbon capture where they'd actually, you know, they put the CO2 in the oil well to get the oil, the residual oil out of it, right? So they definitely like that idea. Yeah, okay, that's, yeah, so yeah, so instead of, you know, doing the normal fracking, they use the CO2 that they capture to then push it into the, yeah, or something to get it out of the rocks. I don't know how it works, but supposedly it works like that. So yeah, I mean, so maybe the oil companies should be out there saying, you know, geoengineering is great and we should do it or something. I don't know, though. They might not be, you know, if these results tell us anything about how rural people would behave, then maybe that wouldn't be too effective. But I don't know.
All right, we have time for one last question.
Sure, thank you for granting short talk. I mean, lots of thoughts came to my mind. I'm very interested in what motivates people. What motivates Vladimir Putin? What motivates Elon Musk? You know, I just imagine here we have this very wealthy hedge fund company. Sure. Yeah. On technology, and I at an event I asked one of the mathematicians who works there, what motivates you?
Mhm.
And he said fear and greed. I said, what do you mean? Well, he said fear that I might lose my clients' money, and greed that I want to get wealthy quickly. Nothing. Oh my God. So I'm gonna really want to say what I would say. Yeah. One thing sort of maybe didn't cover much in your talk was the dimension of time.
Yeah.
What do we mean by that? What motivates us on the short term? Maybe it's lunch waiting outside,
Yeah.
instant gratification, or it might be feeding our family, sure, keeping our house in good repair, worrying about our children.
Yeah.
So, you know, if we went down to Stony Brook Harbor tomorrow morning and the sea level would come up 6 feet, that would change the world instantly.
Yeah.
Right.
Yeah.
But we don't think it's happening that quickly. You see, when you drive down Nichols Road at 5 o'clock, anybody's really trying to cut back on fossil fuels? No. So what, how do we?
Yeah, so I mean, the
dimension
time,
of time.
so yeah, so I mean, of course, you know, human motivations are manifold, right? And you know, but we try to be able to capture some of them in the lab, in these kind of experiments, right? Try to isolate kind of thing, right? That comes at the expense sometimes of, you know, this extra validity problem. And the time thing is a very important thing to study, right? And obviously, you know, that's what makes climate change, one of the features of climate change that makes it such a difficult, so I mean, social limits have inherent problems, right? But the time aspect and the sort of slow boiling frog aspect of it is really problematic, right? And people should study it more. Problem is, I've tried to do these things and tried to convince reviewers that what we're doing is kind of an intergenerational thing, because one group then leads consequences for the next one. But they seem to think the only way you can study intergenerations is actually wait for a new generation or something that, you know, I need to publish something sooner than that, so I can't do it. Maybe I should, but yeah, so it's hard to capture that. It's probably these kind of studies, right? But it's certainly a big factor in people's, you know, unwillingness to do.
People don't want to believe things make them uncomfortable.
That's also part of it, sure, yeah, I mean, it's easier to, you know, hide your head in the sand or whatever, so that's, yeah, so, yeah.
Right, thank you so much.